Assalamualaikum warahmatullahi wabarakatuh, and good morning, ladies and gentlemen. It is my pleasure to welcome all of you here this morning. I hope you have had your breakfast. We'll begin shortly, so stay tuned. In the meantime, we also seek your permission to record this session for 2 days, so we hope it's okay with everyone. All right, so good morning again, everyone. Before we start, we are going to play a couple of short montages. We hope that you enjoy these video montages.
Welcome to Multimedia University, the first Malaysian private university. In 1997, the Malaysian government took steps to transform the Malaysian economy from one that was goods and export-centric towards one that relied on digital technology and emphasized services. Since its establishment, Multimedia University has grown in size, in stature, and in impact, both within Malaysia and across the globe. Now, Multimedia University is widely regarded and trusted for its innovative and useful programs. The university is trusted by the Malaysian government as well as numerous professional, governing and assessment organizations across the world. Their trust is expressed in various rankings, agreements and partnerships with the university. In fact, MMU currently holds a unique position as one of the most preferred university across various industries in Malaysia. This preference is a result of years of hard work as well as the intrinsic nature of MMU. From the get-go, MMU has made it a point that it is part of the international community. It drew talent, input and the knowledge from across the globe, and its deliverables were also to be enjoyed worldwide. Furthermore, by thinking in terms of helping various industries secure better qualified personnel, MMU has been able to come up with cutting-edge academic programs, some of which have no parallel within the country or even the hemisphere. Thanks to this nimbleness, MMU has been able to help Malaysia break into new areas of national interest, which include financial engineering and content creation. Of course, MMU graduates are so sought after not only for their strong technical know-how, but also because their strengths go beyond their academic obligations. Our academicians are also active. Throughout the years, they have collectively proven themselves to be very prolific, not just within the confines of academia, but also in the development of their respective industries. In short, MMU has led the private higher education sector in Malaysia for more than 20 years because it has played an active role in the development of the nation. Where other institutions teach, we inspire. Where other institutions draw a map, we take the leap forward. Where other institutions opine, we do. The future is filled with uncertainty. What is certain, however, regardless of the myriad of issues that face Malaysia and the world, MMU will be there to help its students, graduates, as well as its community find a solution.
Telkom University, a diverse institution. An institution that continually conducts research and produces innovation for the nation development. A campus that has an objective of contributing to the nation. This is Telkom University, the best private university in Indonesia, founded with spirit to contribute to the nation. The dream was started in a 50 hectares campus area laid on Bumi Pasundan, West Java. A place for collaboration and innovation to become a research and entrepreneurial university that is actively involved in ICT-based advancements of technology, science, and art. In this campus, students from 34 provinces of Indonesia and international students from countries around the world are actively involved in research and innovation. Research, innovation, and teaching learning excellence support Telkom University to produce competent graduates who work globally in more than 30 countries. Moreover, Telkom University also has several partnership programs with industries that help students to accelerate their careers. As an excellent ICT-based campus that won SPADA Award, National Award on E-Learning Program, Telkom University continually innovates to adapt to the current challenging situation. With determination to create the solution of the national challenges, Telkom University performs research and learning activities. It leads to several innovations that support the science development. The innovations were supported by 5 research centers, 31 research groups, and startup incubation by Bandung Technopark. All of the research and innovation achievements have led to the status of Best University on Innovation Management Award, awarded by Ministry of Education, Culture, Research and Technology. Besides research programs, Telkom University also manages several community service programs towards the real contribution to the nation. As a campus with the objective to contribute to the nation, Telkom University is the first campus that declares Kampus Merdeka, Merdeka Belajar, a policy of the Indonesian Ministry of Education, Culture, Research and Technology. as the best private university according to UI Green Metric 2021. Telkom University has a commitment to always maintain the natural ecosystem in the campus area to be a sustainable campus. It also affects the learning environment where students and lecturers enjoy the comfortable atmosphere. We believe that all of Telkom University achievements, both national and global, could be acquired through the hard work and collaboration of all Telkom University stakeholders.
Telkom University is committed to producing qualified graduates, research and innovations that are beneficial for achieving the sustainable development goals of Indonesia. Telkom University contribute to the nation and the world.
Together, contribute to the nation in Telkom University.
Okay, and that was the video montages. Right, let's start the opening ceremony now. Professor Dr. Ong Tian Song, General Chairperson of International Conference of ICT 2023. CS Dr. Sazalin Shah Razali, Chairperson of IEEE SMC Malaysia. Dr. ZK Abdul Rahman Baizal, Dean of School of Computing Telkom University Indonesia. Professor T.S. Dr. Lau Siang Ho, Dean Faculty of Information Science and Technology, Multimedia University. Honorable guest speakers, committee members, ladies and gentlemen, a very good day, and on behalf of the 11th International Conference on Information and Communication Technology, I would like to extend a very warm welcome to all of you. So it's been a decade, so congratulations. The 11th International Conference on Information and Communication Technology is jointly organized by Multimedia University Malaysia and Telkom University Indonesia. The theme being accelerating digital transformation for human well-being, which is focusing on the role of ICT as a means to improve the human well-being in several aspects, including but not limited to education, quality of life, security, and healthcare. The conference, which is held virtually for 2 days, starting for today and until tomorrow, delivers a prestigious interdisciplinary conference for researchers, engineers, and students throughout the world to present their most recent ideas, innovations, and trends in the fields of ICT. The conference is sponsored by IEE Systems, MAN, and Cybernetics Malaysia. So thank you. All right, so ladies and gentlemen, without further ado, please welcome Professor Dr. Ong Tian Song, General Chairperson of the conference, to deliver his welcoming speech. Please welcome.
Okay, thank you, MC. So, Professor T.S. Dr. Lau Siong Ho, Dean of Faculty of Information Science and Technology, Multimedia University. Dr. Jack K. Abdurrahman Baizal, Dean of School of Computing, Telkom University. Dr. Sadarisha Lazari, the Chairperson of IEEE SMC Malaysia. Respected keynote speaker, invited tutorial speaker, fellow participant, distinguished guests from Telkom University, MMU, staff, lecturer, and student, ladies and gentlemen, a very good morning and welcome all. First of all, this is my great pleasure to welcome you to the ICoICT 2023 to the virtual platform of Google Meeting. I would like to thank to our local hosts, the organizing committee of ICoICT for the coordination and effort of this event. This year marked the occasion of the first 11th International Conference of Information and Communication Technology, with the conference theme Accelerating Digital Transformation for Human Well-being, which is focusing on the role of ICT as a means to improve the human well-being in several aspects, including education, quality of life, security, and healthcare. The technical agenda for the 11 ICoICT 2023 includes 4 keynotes, 3 tutorials, and 20 parallel sessions from 5 different tracks, namely digital community and society, digital healthcare, machine intelligence, big data and analytics, quality of life and smart living. In this year, we have received 201 paper submissions from 16 countries with 114 papers accepted for presentation. All submitted paper has through a rigorous peer review procedure that assess from their importance, originality, and technical excellence. Each paper was examined independently by at least 3 expert reviewers. I want to close this brief welcome by thanking the entire organizing committee from MMU and Telkom University for their long effort to create a series of events that we hope will be useful and beneficial for you. We would like to pay tribute to all our keynote speakers, tutorial speaker, moderator, session chair, student helper, and all presenters. I also wish to acknowledge all paper reviewers who went through the hard time of reviewing all submissions. Last but not least, special thanks to the management of MMU, Telkom University, as well as IEEE SMC Malaysia chapter as a technical support. The conference would not be successful without your full support. So thank you. I think that's all for me. Thank you, everyone.
Okay, thank you, Professor. Right. Next, let us invite, yes, Dr. Sazalin Shahrazali, Chairperson of IEE SMC Malaysia, to delight us with his speech as well. Please welcome.
Hello, Assalamualaikum, everybody. Good morning. Can you hear me?
Yes, we can hear you.
Okay, my apologies because my web camera cannot start this morning. Although I have tested it yesterday, I'm very, very sorry to the organizer and participant. Okay, first of all, thank you very much to the local host for inviting SMC chapter, Malaysia chapter, and me for this event. And congratulations to the organizing committee for ICoICT 2023 for their beginning of the second decade of their organization. Multimedia University Melaka, Malaysia, Telkom University Indonesia, with the cooperation of our chapter, IEEE SMC Malaysia chapter in Malaysia. Also, special congratulations to Professor Dr. Ong Tian Song, the steering committee, Professor Technologist Dr. Lau Siong Ho, the Dean of FIST MMU, and also Dr. Zack K. Abdul Rahman, the Dean of School of Computing, Telkom University, Indonesia. It is very interesting to have this 11th version of the ICoICT with the theme Accelerating Digital Transformation for Human Well-Being. I can see that there's a well-balanced technical program, very interesting, with the industry chiefs will be giving the keynote. I would surely think that this is beneficial to participants and also students that are attending. I would take this opportunity to encourage all participants and also committees to join IEEE and also systems, man and cybernetics, SMC, Society Malaysia chapter if you are in Malaysia. If you are in Indonesia, you will automatically be added to the SMC in Indonesia. For the faculty members, industry players, postgraduate students. For undergraduate students, if you join IEEE, you can join the student branch, I think available there in Multimedia University Melaka. So I would say thank you very much to all. Congratulations again. And may the conference ICoICT 2023 is a success for these 2 days, and this collaboration would continue in the future for the many decades to come. That's all from me. Again, my apologies for the web camera not working. Thank you very much. Assalamualaikum.
Walaikum salam. Thank you, Doctor. That was very inspiring. All right, and finally, allow me to invite Professor Dr. T.S. Dr. Lau Siang Ho, Dean Faculty of Information Science and Technology of Multimedia University, to deliver his opening speech. So please welcome.
Okay, thank you, Master Ceremony, Miss Nur Arabika. Okay, a very good morning. Dr. Z.K. Abdul Rahman Baizal, Deans of a School of Computing, Telkom University. T.S. Dr. Sazalicia Razali, Chairperson of the IEEE System Man Cybernetic Malaysia. Prof. Dr. Ong Teng Song, General Chair of ICoICT 2023, Multimedia University. Distinguished keynote speaker, tutorial speaker, guests from MMU and Telkom University, ladies and gentlemen. Thank you to each and every one of you for being here with us this morning. It gives me a great pleasure to have this opportunity to be among you today to make this opening speech for the 11th International Conference on Information and Communication Technology, ICoICT 2023, jointly organized by Multimedia University Malaysia and Telkom University Indonesia. This year theme, Accelerating the Digital Transformation for Human Well-Being, which highlight the role of ICT as a mean to improve the human well-being, including but not limited to education's quality of life, security, and healthcare. Digital technology is a fundamental force, okay, for the change in this century. It is reshaping all types of society, including economy, governments, and civil society, thereby impacting almost every aspect of people's life. The exponential pace of digital revolutions and its profound consequences demand a better understanding of the new context, as well as an intentional and inclusive design of a digital transformation effort to ensure that no one is left behind. This conference is held virtually via an online conference platform, and it's deliver a prestigious interdisciplinary conference for researchers, engineers, and students throughout the world to present their most recent idea, innovations, and trend in the field of ICT. The previous ICoICT conference have successfully served as a forum to bring together a diverse group of people from academics and industry to share and present the latest issue and also recent development in the area of ICT. Ladies and gentlemen, for your information, this conference is technically sponsored by IEEE System Man and Cybernetics, SMC Malaysia. And all accepted paper will be submitted for inclusions of IEEE Explore subject to meeting the IEEE Explore scopes and quality requirements. I was informed a total of 201 papers were received, and only 114 papers were accepted for publication, which is the equivalent of about 56% of the acceptance rate. Proceeding from the previous ICoICT, okay, I have been published in IEEE Explore and indexed by the Scopus. Before I conclude, I would like to thank the organizing committee for organizing this conference to provide a platform for academicians, industry, professionals, and students to exchange knowledge and sharing research finding in a broad scope of coverage of ICT. This collaborative effort, I must say, is very commendable and should be continued in future. To all distinguished speakers for giving their time and insight, to all participants for committing your time and energy towards this conference, I would like to thank and wish all of you best and have a fruitful discussions. In closing, without further ado, I hereby declare the 11th International Conference of International and Communications Technology, ICoICT 2023, officially open. Thank you, and I look forward to seeing you next year. Thank you.
Okay, thank you, Prof. That was Dr. T.S. Dr. Lau Seong Ho, the Dean Faculty of FISD, Multinational University. With the opening speech just now, the 11th International Conference on ICT is now open. Do stay with us throughout the 2 days of this exciting event as we have prominent speakers and sessions mainly from South Korea, Indonesia, and Malaysia. Before we end this morning session and take a short break, I would like to invite everyone to open their cameras for a quick photo session. Right, can we have everyone to switch on their cameras so our committee can take a picture? Are we good, Mr. Suman? Okay, we have most of everyone to open their cameras now.
Okay,
All right.
we have taken a few shots.
Whenever you're ready, Mr. Suman.
Yeah, we have taken a few shots already.
Oh, okay. Okay, maybe one more last shot just to make
Okay,
sure that everyone is. Okay, I'm going to count to 3, 2, 1. Smile.
all right,
All
great.
right. Thank you, everyone, for your cooperation. All right, now let's take a short break, and I think we'll meet again at 10:15 for the first keynote speaker session. Thank you very much.
The first Malaysian private university. In 1997, the Malaysian government took steps to transform the Malaysian economy from one that was goods and export-centric towards one that relied on digital. The university has grown in size, in stature, and in impact, both within Malaysia and across the globe. Now, Multimedia University is widely regarded and trusted for its innovative and useful programs. The university is trusted by the Malaysian government as well as numerous professional, governing and assessment organizations across the world. Their trust is expressed in various rankings, agreements and partnerships with the university. In fact, MMU currently holds a unique position as one of the most preferred university across various industries in Malaysia. This preference is a result of years of hard work as well as the intrinsic nature of MMU. From the get-go, MMU has made it a point that it is part of the international community. It drew talent, input and the knowledge from across the globe, and its deliverables were also to be enjoyed worldwide. Furthermore, by thinking in terms of helping various industries secure better qualified personnel, MMU has been able to come up with cutting-edge academic programs, some of which have no parallel within the country or even the hemisphere. Thanks to this nimbleness, MMU has been able to help Malaysia break into new areas of national interest, which include financial engineering and content creation. Of course, MMU graduates are so sought after not only for their strong technical know-how, but also because their strengths go beyond their academic obligations. Our academicians are also active. Throughout the years, they have collectively proven themselves to be very prolific, not just within the confines of academia, but also in the development of their respective industries. In short, MMU has led the private higher education sector in Malaysia for more than 20 years because it has played an active role in the development of the nation. Where other institutions teach, we inspire. Where other institutions draw a map, we take the leap forward. Where other institutions opine, we do. The future is filled with uncertainty. What is certain, however, regardless of the myriad of issues that face Malaysia and the world, MMU will be there to help its students, graduates, as well as its community find a solution.
Telkom University, A diverse institution. An institution that continually conducts research and produces innovation for the nation development. A campus that has an objective of contributing to the nation. This is Telkom University, the best private university in Indonesia, founded with spirit to contribute to the nation. The dream was started in a 50 hectares campus area laid on Bumi Pasundan, West Java, a place for collaboration and innovation to become a research and entrepreneurial university that is actively involved in ICT-based advancements of technology, science, and art. In this campus, students from 34 provinces of Indonesia and international students from countries around the world are actively involved in research and innovation. Research, innovation, and teaching learning excellence support Telkom University to produce competent graduates who work globally in more than 30 countries. Moreover, Telkom University also has several partnership programs with industries that help students to accelerate their careers. As an excellent ICT-based campus that won SPADA Award, National Award on E-Learning Program, Telkom University continually innovates to adapt to the current challenging situation. With determination to create the solution of the national challenges, Telkom University performs research and learning activities. It leads to several innovations that support the science development. The innovations were supported by 5 research centers, 31 research groups, and startup incubation by Bandung Technopark. All of the research and innovation achievements have led to the status of Best University on Innovation Management Award, awarded by Ministry of Education, Culture, Research and Technology. Besides research programs, Telkom University also manages several community service programs towards the real contribution to the nation. As a campus with the objective to contribute to the nation, Telkom University is the first campus that declares Kampus Merdeka, Merdeka Belajar, a policy of the Indonesian Ministry of Education, Culture, Research and Technology. As the best private university according to UI Green Metric 2021, Telkom University has a commitment to always maintain the natural ecosystem in the campus area to be a sustainable campus. It also affects the learning environment where students and lecturers enjoy the comfortable atmosphere. We believe that all of Telkom University achievements, both national and global, could be acquired through the hard work and collaboration of all Telkom University stakeholders.
Telkom University is committed to producing qualified graduates, research and innovations that are beneficial for achieving the sustainable development goals of Indonesia. Telkom University contribute to the nation and the world.
Together, contribute to the nation in Telkom University.
Hold on, brother, hold on, the road is long.
All right, hello everyone. Good morning. Right, we're going to start shortly, so just going to prepare a few things. Please stay tuned with us, yeah?
Hello, can you hear me?
Yes, yes.
Okay, great. Thank you.
Morning, sir.
Good morning.
All right. Good morning and welcome back, everyone. Just remind everyone that this is a recorded session, so I hope everyone is okay with it. All right, distinguished guests, ladies and gentlemen, allow me to invite our moderator for today, Associate Professor Dr. Shi Yin, to introduce our first keynote speaker of the day, Professor Dr. Seong Ji Kyung from Sejong University, South Korea, with the title of presentation, Machine Learning for Computer Vision. Please welcome.
Hi, thank you, Ms. Speaker. So I will be the moderator for this session. So ladies and gentlemen, distinguished guests and esteemed participants, it is my great pleasure to introduce to you a seasoned professional and true expert in the field with a wealth of experience and patience for fostering insightful discussion. Our keynote speaker for this conference is poised to guide us through a journey of knowledge, sharing, and meaningful exchange. Without further ado, let us delve into his impressive biography to better understand the depth of expertise he brings to ICoICT 2023. Prof. Dr. Song Gun Kong received the Bachelor of Science and Master of Science degrees from Seoul National University, Seoul, Korea in 1982 and 1987 respectively, and a PhD degree from the University of Southern California, Los Angeles, United States in 1991, all in electrical engineering. He was an associate professor in the Department of Electrical and Computer Engineering, the University of Tennessee, Knoxville, and Temple University, Philadelphia, United States. He is currently a professor of computer engineering at Sejong University, Seoul, Korea. So his research interests include image processing, computer vision, and intelligent systems. Dr. Kong received the most cited paper award from the Computer Vision and Image Understanding Journal in 2007 and 2008. The Honorable Mention Paper Award from American Society of Agricultural and Biographical Engineers in 2005. His professional services include an associate editor of the IEEE Transaction on Neural Network and Learning Systems, a guest editor of a special issue of International Journal of Control, Automation and Systems, as well as Journal of Sensors. So now armed with a profound understanding of our distinguished speaker's achievement, it is an honor to hand over the stage to Prof. Song as he delves into his keynote address, enlightening us on the captivating realm of machine learning for computer vision. So hi, Prof. Song. We are truly privileged to have you here, and I kindly request that you keep within the allocated time of 45 minutes for your presentation. So let me pass the sessions over to you, and it's yours now, Prof. Song. Happy to see you.
Thank you for your kind introduction, Dr. Oishin. It is my great pleasure and honor to give a talk in this conference. I'd like to thank the chairs and organizers of this conference. Today, I'm glad to share with you some of the aspects of machine learning and computer vision. Let me share the screen with you. Okay, is it good? Can you see the screen that I'm sharing?
Yes, Prof. But
Okay.
we are not seeing the presentations mode.
Okay.
I mean, we can see the slides, but it is not the presentations mode.
Okay, can I continue?
Yes, you may.
Okay. All right. Today I'm going to share with you some of the aspects of computer vision and machine learning under the title Machine Learning for Computer Vision. And I have a subtitle, From the Boosting Idea to Deep Learning. Here is an outline of what I'm going to share with you today. I'm going to start with some promises and challenges of computer vision, and I'm going to discuss conventional and machine learning approaches to this problem. And we have a fundamental issue with object detection and classification, which is the bias variance trade-off. And to tackle this issue, we have been working on ensemble learning all the way to the deep learning. So I'm going to focus on the boosting idea and the deep learning ideas, and then I'm going to conclude this talk. Okay, here is an overview of computer vision and artificial intelligence. First of all, artificial intelligence enables machines to perform tasks that would normally require human intelligence. Some of the examples include learning, reasoning, or inferencing, and making decisions. On the other hand, the computer... I'm sorry?
I'm so sorry, but if you don't mind, I would like to just let you know that your slides is not moving.
Oh.
Yes.
Okay, can I try it again?
Yeah, sure.
Okay, I'm just sharing the screen. I'm using presenter mode. How about now?
So now I'm seeing the slides of the third slides, computer visions and AI.
Okay, and then can I make it a full screen?
Yes, but we didn't see the full screen. You may want to try and make it into full screen.
Oh, okay. So should I use the current state? So if I make it a full screen, then it is not visible to you?
It's not moving. We are still seeing the presentation. How about Prof? Let us present for you.
Okay.
Okay. Please give us a second. Yeah? I'm seeking help from the secretariat. So let us project the screen. Let us project the slides for you, if you don't mind.
Okay.
All right. Give me a second. Yeah.
Okay.
Prof. Sean, you just sent us the slide. Hi, Prof. Sean.
Yes.
I'm Dr. Go here. You just sent us the slide. Then we can present on behalf of you, and then it will be easier.
Okay. If the slideshow doesn't work, then I'll try to use, just go one by one.
Hi, Prof. I'm Sumindra
Hey,
here. If I could
yes,
just guide you through for the presentation mode. The first thing, can you exit the sharing at the moment? Then I will guide
okay,
you through how to do for the presentation mode.
okay. I
Right.
start the
So at this
sharing.
point, in your slides, PowerPoint slides, there will be one option at the bottom where you have to select for the presentation mode.
At the bottom,
Yeah. Where you can have your magnifying for zooming in and zooming out at the bottom over in your presentation slides.
you mean this one?
Did you notice that, Prof? There is one icon which has the
The
screen.
presentation slideshow,
Yes.
right?
Yes. If you
Yes,
select that,
yeah,
okay,
I just
once you've
selected it.
selected that, and then from your Google Meet, you can select on the presentation and you can select on the entire screen.
Okay.
And you will observe there are multiple screens being displayed over there, and you can select the screen that shows the full screen of your PowerPoint slide.
I think I'm using a single monitor, so
Huh.
that's probably why, I think.
Okay. If that is the case, you can select on the Windows as well. Windows also will display on multiple different options. Then you can select on the full screen mode of your PowerPoint slides.
Okay, I think I better go without a slideshow.
Okay, sure.
Okay, sorry for any convenience.
No
So,
problem, no problem.
okay, so now I'm going to share the screen one more time. Oh, I may lose slideshow feature, but it's not a big deal. One more time, I'm sorry for any inconvenience because of this. I hope you can recognize the letters and the figures on the screen. Okay. All right, can I proceed now?
Yes, Prof.
Okay, thank you. All right, so the computer vision enables computers to interpret and understand visual information from the world. The computer vision extracts descriptive and meaningful information from the visual data, such as images and videos. This is a definition for computer vision. And some of the tasks within the computer vision should be to discover from the images or videos what is present in the scene, which is refers to object detection, and where things are, which refers to localization of the object, and what actions are taking place refers to the behavior recognition. And here in this image, there are several objects in the scene with the proper labels such as car, person, horse, and the bounding boxes that indicates the location of the object detected with confidence labels such as 0.993 indicates the level of confidence or the probability that the detected object should belong to a certain category. The object recognition is a fundamental task in computer vision, which involves identifying and classifying objects within an image. It analyzes visual features to determine the presence and the type of object. So in this figure, there is a large cat in the image. This is what we see. However, the computer sees a bunch of numbers indicating the level of light reflectance, I mean the brightness level, in 3 channels, red, green, and blue. So the computer perceives a bunch of numbers, and that is one difficulty involved in computer vision, because the machine or the computers should deal with a large amount of numbers. And from those numbers, the computers are required to make a decision that the object in the image can be a cat with 82% of confidence level, and so on. There are some challenges on the computer vision. One of the challenges is the variations in the viewpoint. So as you see here, the same object taken from different angles, the appearance varies quite significantly. So all these 3 images are from the same object. However, from different viewpoints, the appearances are quite different. And the difference in illumination also creates a problem. And if an object is well illuminated, then it will be always an ideal case. However, because of some changes in the illumination and lack of illumination, we have a difficulty detecting and recognizing the object in the image. And the others include object interclass variation. All these objects with different appearances belong to one category. As you know, all these are different shapes and appearances of the chair. So there is a large variation within the class. This is another challenge. And the deformation can be a problem too. So you can imagine a cat has 4 legs and standing or sitting. However, sometimes cat is a remarkably flexible animal. So there can be a large deformation of the object, which changes the appearance, visual appearance too. Okay, other challenges include occlusion, because in some cases objects are occluded by other objects, so only a part can be detectable. And the background clutter is also a difficulty, because we have an object of interest standing in front of a cluttered background. Because of that, computer vision faces a big challenge detecting object interest from cluttered background. Scale variation also gives us a problem because the sizes of the objects vary. That gives us another challenge. So to deal with all these difficulties, people have been working on conventional and machine learning approaches to these problems. Conventional approaches rely on well-defined rules or mathematical operations and handcrafted features to analyze and interpret visual information from images and videos. However, on the other hand, machine learning involves training algorithms to learn patterns and features directly from the data. And it able to understand and make decisions based on the visual information. So in the next slide, I'm trying to describe what machine learning is about. Machine learning is a subfield of artificial intelligence, which is concerned with the development of algorithms and models that enable computers to learn and make decisions from the data without being explicitly programmed for each specific task. So in this diagram below, the conventional approaches attempt to extract features, and based on the handcrafted features using a decision theory, we make an hypothesis function to make a proper decision to predict the nature of the object. However, in machine learning algorithms, it goes directly from the data to developed algorithms or detection models to be able to predict or classify or detect the object in the scene. And in machine learning improves the performance over time through learning. So learning is a fundamental feature of machine learning and artificial intelligence. The machine learning allows computers to learn patterns from the data directly to make accurate decisions on new and unseen data. So now let's consider what machine learning is. Machine learning has several features, such as feature learning. It automatically learns relevant features directly from the data. And it has an end-to-end learning because it skips the necessity to extract features from the data. So sometimes the success of the conventional approaches heavily rely on the successful features. However, machine learning algorithms can learn tasks end-to-end fashion from the raw input to desired output. And it has an adaptability feature that can adapt to varying light conditions and different viewpoints and complex background and so forth. Okay, here are some other features of machine learning. It has a generalization and scalability, generalization capabilities, which is very important. Once we succeed on learning, the real issue is the success with the test data, which refers to the generalization issue. The machine learning can generalize the patterns from a data set to new unseen data, which is very important. And it has a transfer learning feature so that machine learning algorithms, once trained, can be fine-tuned for other specific tasks. That's why most people rely on pre-trained models to be able to adapt to a specific task. Interpretability allows researchers to visualize and understand what the model has learned and aiding in the decision making and so on. Okay, in machine learning, we have several different learning schemes. typical learning schemes include supervised and unsupervised learning, and also reinforcement learning. So let's just consider supervised learning. In supervised learning, models trained on labeled data, and the input data and the corresponding correct output are provided. So in machine learning algorithm, we have labels. That's why it gained the name supervised learning. And based on the supervised learning, we use a machine learning algorithm to train the model to be able to perform a specific task. On the other hand, unsupervised learning without predefined labels, machine learning models are trained on unlabeled data without label, so that the model can possibly figure out the pattern or the trend within the data. Okay, here in machine learning algorithms can be categorized into four types. In computer vision, we are trying to use classification or categorization features, which is related to supervised learning and discrete. And the others are also other variants of machine learning algorithms. But in computer vision, we are trying to use a classification models to be able to recognize the object of interest in the scene. To make it simple, the machine learning framework can be described as a simple function like this. For given input x, we use an hypothesis function to generate an output. According to the training, we develop the model hypothesis function, and actually we fine-tune, we adjust the parameters of the hypothesis function using a set of labeled examples. So basically, we use a supervised learning scheme to develop the hypothesis function, and the function h is developed by minimizing the prediction error on the training set. Once the hypothesis function is trained, then we use a testing. In the testing phase, we apply the trained hypothesis function h to an unseen test samples x to produce the prediction output. So this is what we are going to do basically. But some of the approaches can be more systematic and mathematical models, such as a linear decision boundary like this. So suppose we have two sets of data belonging to two separate sets, then we are going to find out decision boundaries separating the data into two distinctive sets, distinctive classes. So this is one task. However, there is a more heuristic way of doing it. So in the next slide, here is another examples of finding or determining the classifiers. As an example, in nearest neighbor algorithm, we use prototypes within each categories to test for given test example. We are trying to find the similarity between the test example and the prototypes in the class. So often we measure the distance as a similarity metric to be able to classify a given test example. We determine in which class it belongs. So in heuristic approach, no training is required. However, we need a certain amount of prototypes. So image classification is a task to assign a label to given object in the image. So for example, for given images, using a trained hypothesis function, we are going to make a decision if this image belongs to a class of apple or class of tomato or class of cow and so on. To achieve this goal, we are using the training and testing phases. We go through training and testing. For given universal set, we have a subset, which is a training set, sampled from the universal set. So given a subset of training data, so we are developing decision boundaries, either linear or nonlinear. And after that, we apply the trained model having certain decision boundaries to the test set. The test set are obviously were not observed in the training phase. So once it is done, we are going to evaluate the performance of the model in terms of object detection or classification. So in general, we go through training and testing phases like this. Here in training phase, for a given training set, we go through feature extraction, and for given model with a certain set of parameters, then using a label assigned to each data. So we fine-tune the parameters, and then we develop a learned model. This learned model will be used to make a certain action on the test image to make a prediction. So here is a generalization issue. How well does a learned model generalize from the training data to unseen test data? This has been a crucial issue in machine learning and computer vision. Okay, so even though we are trying to collect as many training data as possible, but the amount of training data is not always sufficient. So therefore, the issue is, even though we collect a large amount of data, and once the model is trained, so can the trained model successfully generalize to new data? That has been a crucial issue in machine learning and computer vision. In this issue, we have two aspects that are responsible for generalization error. One is the bias and the other is the variance. So often we call it bias variance dilemma or bias variance trade-off and so on, because it is a central problem in supervised learning, because there exist two sources of error in data feeding process or in object detection process as well. The bias refers to the difference between the expected prediction of the model and the correct value. So in short, bias is about how far off the model's predictions are from the correct value. On the other hand, the variance refers to the variability of a model prediction for a given data point. So this is about how much the predictions for a given point vary between different realizations of the model. So we can conveniently visualize the the natures of bias variance using these figures. Here, target and the bullet marks. Okay, the first image we have tightly clustered bullet marks, which refers to low bias and low variance, which is good. However, the one on the right here, it has high variance and low bias because the bullet marks are centered at the bull's eye. However, it has on average. However, it has quite a large variance. That is a case of high variance and low bias. And here, high bias and low variance case, as you see here, we have a tightly clustered bullet marks. However, all those marks are off the center. So what we are trying to do is we are trying to reduce the variance and the bias. Unfortunately, there is an issue called no free lunch theorem, which I'll go over in just a minute. So after I skipped the derivation of the bias and variance, if we represent the mean squared error of approximation, and then we can divide the mean square error of approximation into three terms. The first term should be the square of the bias. The second term is the variance, and the last term is an unavoidable error. Because we assume that there is a Gaussian error when we collect the data, there is an uncertainty which is described as Gaussian noise with zero mean and the variance of sigma square. So therefore, the third term right here is an unavoidable error, which we cannot, which we should accept. Okay, so other than the unavoidable error, there are two terms. The one is the square of the bias, and the second term is the variance. So the first term is the error due to oversimplification, and the second term, the variance, is the error due to inability to perfectly estimate the parameters. So we have to deal with these two errors, bias and variance. How can we reduce the bias and the variance? However, as I just mentioned, there is a no free lunch theorem, which means if we try to reduce the bias, then the variance goes up and the vice versa. Okay, so once we try to reduce the bias and the variance increases, however, if we try to reduce the variance, then the bias goes up. So therefore, we should make a balance between the two. That is the nature of the bias and variance trade-off. So an ideal model should accurately capture the regularities in the training data. Therefore, it should be flexible enough. Okay. And an ideal model should be able to generalize well to unseen data. However, because of the bias and variance, it is always there exists a difficulty achieving an ideal model. So how can we deal with the bias and variance? The bias decreases with more complex model. So I think we can easily avoid the bias problem because if we use a sufficiently complex model with large amount of parameters in it, then we should be able to avoid a bias problem. Okay, that means the complex model. Okay. However, if we use complex model, but without a large amount of data, then we may face overfitting issue, which is the high variance problem. So when we try to decrease the bias error, we can increase the complexity of the model. However, if we increase the complexity of the model, then the variance will go up. Variance will increases. So so it goes always in the contradictory way, as I just mentioned from the no free lunch theorem. So how can we do it? So people have used some of the bright schemes, such as the ensemble learning schemes and deep learning schemes to tackle the bias variance trade-off. Okay, so just to refresh on the underfitting and overfitting, if the model is too simple, then it has limitations to estimate the nature of the data, the trend of the data well. However, if the model is too complex, we have a problem of overfitting. So we have to deal with both bias and variance problems. So as an indication, in terms of the complexity of the model, if the model is too simple, then we may face high bias and low variance problem, which has high error on training and high error on the testing also. However, if our model is too complex, but without a large amount of data, then we may end up with overfitting, which gives us really low error for training data, but high error on the test data. So therefore, we cannot achieve generalization capabilities. Okay, let me skip some of the slides here. So as a conclusion, we should deal with, we should make a good balance between the variance and bias error to maintain a low total error. So we should maintain a good balance between the two. So when we try to do this, there has been an ensemble learning scheme to address this issue. The ensemble learning involves combining multiple individual models, often called learners, to create a model, more robust and accurate predictive model. So we are using multiple weak models, as we say, by combining the predictions of multiple weak models, then we are trying to achieve the overall performance improved compared to using any single model. So ensemble learning has been useful for improving generalization capabilities and reducing overfitting and enhancing the model's ability to capture complex patterns in the data. Some of the good examples include bagging and boosting. Here is this slide describes the idea of bagging. In bagging is an abbreviation for bootstrap aggregating. The idea is quite simple. For given training set, we divide the training set into multiple subsets by sampling with duplication allowed to create several subsets. And then using each subset, we perform a supervised learning to develop a weak learner. And for using subset number 2, we develop another weak learner, and so on. And based on all the predictions of the weak learners, we are going to aggregate to make a decision. This is the idea of bootstrap aggregating. And let me just show you another slide describing the boosting idea. And the boosting idea also uses multiple models trained on multiple training sets. However, the way we divide the training sets are different. So for a given training set, we are going to use a certain subset and then perform a training to develop a weak learner. And then we are going to test it, and then we are going to detect the errors, training phase, to develop another weak learners, and so on. So the errors are useful to strengthen the performance of each learners. And in the last stage, we are going to combine all those predictions to be able to derive a strong learner. Okay, let me just show you a sequence of illustration. Sorry, I wasn't able to show you a slideshow, which is quite, informative, because it is it has some animation feature. But let me try anyway. So here, for given two sets of data, the red colored data and the blue colored data, in the first phase, so we use a weak learner or weak classifier generating this simple linear descent boundary. Okay, so using this simple linear descent boundary, we have some of misclassified samples like this. Okay, so these samples will gain higher weights here to represent the higher weights assigned to those misclassified data. I use bigger circles. So these data are misclassified using the first model, so that weights are increased. In the next slide, we use another classifier, another weak classifier, to classify the two sets of data. So here we have another misclassified samples like this with an arrow on it. And then the next phase, we are going to increase the weights to those misclassified data. And then we are going to use another weak classifier, which is this. And this data is also misclassified. So by combining the classifiers of those three weak classifiers, we can generate a piecewise linear descent boundaries that successfully separate two sets of data without an error. So this is an idea of the boosting. So in earlier days of computer vision, people have used this idea to successfully detect the face in the image. There is an algorithm called ADA boost, which refers to adaptive boosting, which has been most popular boosting algorithm and successful also. And based on this ADA boost algorithm, people have used this ADA boost idea to classify, to detect the face in the image. The face detection is a binary classification problem because we are trying to detect the face versus non-face in the image. So here in this diagram, we detect face in the images using AdaBoost. So it has been quite successful in earlier days. The most popular algorithm in the past was the Viola-Jones face detector. This algorithm based on the AdaBoost, adaptive boosting idea, to be able to detect the face in real time. Okay? It has been a similar approach to real-time object detection. So in the early 2000s, when the performance of the hardware was not like these days, with the limited capabilities of the hardware, this algorithm was quite successful in terms of the performance and the speed. So the key ideas behind the Viola-Jones face detectors should be a boosting idea for feature selection and interior image for fast feature evaluation and attentional cascade for fast rejection. So based on this idea, people have used for detecting a face in the image. People use a large amount of data for training and also variations. So across individuals and variations in the image, illumination and the variation in pose. So by diversifying all those images for training, and then people were able to detect face in image. Because of the feature of fast rejection, for given image like this, containing a large number of face object in the image, if we go in sequence, then first, the portion of image that cannot be quite a face object are rejected in early stage so that it saves a large amount of computation. And it keeps going by rejecting the regions of image to be able to perform a fast computation. And finally, we were able to detect the face. And this has been a quite popular results in face detection. Okay, this is quite a classical approach in early days of computer vision, but more recently, people use a deep learning idea to address the bias variance trade-off. For deep learning has been successful in more recent days because it uses a trainable feature extractors, a sequence of trainable feature extractors. Usually we use CNN, which is convolutional neural networks. So for given image containing an object of interest, we use a stack of CNNs to be able to extract the features. And then finally, we use a trainable, fully connected layers as the classifier to make a decision. To go over briefly what CNN is about, CNN is also a kind of artificial neural networks, but it has consists of neurons and learnable weights, and it finds class scores from raw image pixels. So we can consider CNN as specialized neural networks for image analysis and computer vision. So CNN is specifically designed for processing grid-like data such as images and videos. So therefore, CNNs are quite efficient for representing the functions involved in visual recognition. Okay. And also it has deeper layers to be able to learn the higher level features. So as we go through more layers, deeper layers in convolutional neural networks, we extract features. And as we go through deeper layers in CNNs, we can extract higher level features. So this diagram is an example of an architecture of CNNs. For given input, it goes through several convolutional layers to extract the features. So basically, the CNNs consist of two parts: the feature extractor layers and the classifier layers. Okay, so convolution layers extract features, and the pooling layer removes uninformative halos, and then finally the fully connected layer matches an input image with all the templates to be able to classify an object in this scene. Okay, the convolution layer behaves like the eyes of CNN. So therefore, actually this is an animated GIF, but I'm sorry, I wasn't able to visualize it properly. But anyway, it looks for specific features to produce high activation. So when we are trying to detect a specific feature, such as horizontal edges or vertical edges or the corner point like this, we use a special corner of the filter to be able to detect those features in the image. Okay, so as a result, a convolution layer, as we go through multiple layers, we are able to generate higher level features. That is the convolution layer, and the pooling layer reduces the spatial dimensions of the feature maps, but still it keeps the core information, core visual information of the object in the scene, but we were able to reduce the data size to be able to increase the speed of the processing. So there are max pooling and average pooling. Depending on the purpose, we can choose either max or average pooling to be able to remove unnecessary data while keeping the key information, key visual information in the scene. Okay, the pooling area layer downsamples the volume spatially, and it can avoid overfitting with fewer parameters because we reduce unnecessary information from the scene, so that we can reduce the amount of parameters to be able to avoid overfitting issues. Okay, and then finally, the fully connected layer makes a decision. It has two phases: a forward pass, which is the inference, and backward pass, which is training. And finally, the fully connected layer makes a decision on object detection and classification. All right, and then I'm going to skip a couple slides because of time. And I'm going to share with you some of the results of the previous ILS VRC challenge. that has been performed over 10 years. It is really a large-scale image classification competition. Has a really large amount of object classes with a really large amount of data. So before then, it was quite individual execution of the algorithms. But from this challenge, people were able to compete with each other on a same benchmark data set to compare their performances. So here is a quite well-known graphs on the winners of ILS-VRC competition. Starting 2010, okay, this, by the way, this is a graph of top 5 classification errors versus number of layers. The first 2 winners in 2010 and 2011, these are just a regular neural network based approaches. However, in 2012, the AlexNet was known as the first CNN-based winner. So starting 2012, the CNN has been considered as a key player in object detection and computer vision. In the previous years, 2010 and 11, because at each year it has only 3% decrease. So people expected another 3-4% decrease in 2012. However, the AlexNet was able to reduce the error quite significantly, more close to 10% decrease from 25.8 to 16.4. So AlexNet at that time was quite successful because of that. And the next year, it has been improved with more hyperparameters. Tuning of hyperparameters over AlexNet was able to decrease the error even more. And in 2014, actually there are 2 winners, which are VGG and GoogleNet, quite comparable models, having 19 layers and 22 layers. So from 2014, we start having more layers. So from shallow network, people were able to increase the depth of the layers into 8 layers to 19 layers and even 22 layers. Okay, and the next year, 2015, the number of layers has been dramatically increased to 152 layers in ResNet network. So in the year 2015 and 2016 and 17, people were able to decrease the error into even lower than 3%. But just to compare the performance with human result, which is about 5%. So we can make a conclusion that the deep learning approach is even better than human approach, because human error was about 5%. However, the deep learning approaches achieved the error lower than 3%. Okay, from these graphs of the winners of ILS-VRC competition, we learned quite several things. First of all, the deep learning approach was quite powerful in computer vision and object detection and classification. And it is even better than human capabilities. But sometimes it is confusing to human to make any decisions. However, the deep learning approaches were quite successful to beat the bias and variance trade-off. Okay, to summarize what we have discussed so far, in the past, in early days of computer vision success, people used the boosting idea to avoid the bias variance trade-off, the bias variance problem. The boosting idea is recognized as a seminal approach to real-time object detection, was in boosting idea and bagging also, it uses multiple weak learners, multiple models, and then combine the predictions of each model to be able to make a better decision. So the boosting idea is to combine multiple weak learners, weak models to produce a strong model. And at each iteration, only misclassified samples, which are considered as difficult samples, got higher weights. And then these hard data samples are used in the next training phase to gradually increase the performance of object detection. So the boosting idea has achieved a notable success of machine learning in computer vision in early days of attempt. More recently, we have been successful on computer vision using deep learning models. It is a branch of machine learning based on artificial neural networks. However, it is specifically tailored to process visual information in the image. Deep learning automatically learns feature representation directly from training data using a sequence of CNNs to extract the features explicitly. And so therefore, deep learning has been known as an end-to-end approach for computer vision. Deep learning has a feature of learning hierarchical representations. And as I just showed you, from the IRS VRC competition, deep learning approaches have won image classification competitions, even considered better than human. So this concludes my talk. Let me stop sharing and get back to screen. One more time, I'm sorry for some technical difficulties because I prepared some animations and slideshows, but I wasn't familiar with Google Meet. So I'm sorry one more time for the technical difficulty. I know this is time, but if you have any questions, I'll be happy to answer any of questions, if I may.
Thank you, Prof. Song. And yes, please don't say sorry. We are also sorry as well to cause the troubles for you to project it. So, Prof. Song, thank you so much. So this is a big thank you to Prof. Song for the enlightening talk on machine learning for computer vision. Okay. So for the rest of the floor, thank you for engagement. So you may start to raise any questions, okay, to Prof. Song, right? So maybe let me start first. Okay. Oh yeah, we received one request from Yusuf. Great. Okay. So perhaps I start my first. So let me take my privileges to ask Prof. Song. Okay. So I have one question to Prof. Song. So if let's say if I would like to consider individual layers or maybe a block within the CNN, which I view them as the weak learners. So do you think that I can apply the boosting techniques to focus maybe on a certain layers that can contribute more to the final prediction?
Yes, I think the boosting idea is quite successful. So even though there are other approaches like begging and others in the category of ensemble learning, and ADA Boost has been quite powerful scheme to machine learn to computer vision. So I think it will be quite successful on that. So that is I think I think boosting idea is a key player in ensemble learning.
Okay, thank you. Thank you so much, Prof. Song. Okay, so perhaps we open to the floor, and I received one request from Dr. Yusuf. You may raise your question.
Yeah, yeah. Can you hear me?
Yes.
Yeah.
Yes.
First, thank you so much, Prof, for the presentation. Very informative. So my question is, sometimes as we facing a problem, we want to collect the data, and the problem is if you collect the data, now we have the data. So how we can tell this is actually like a representative for the problem distributions? So you collect a huge amount of data, but you want to say, okay, this is actually more than enough for this problem. Uh, I mean, we have any kind of benchmark or say, or like a bunny, so we say, okay, this is enough, now we can go for training and testing on these ones, because the generalizability, so it's a big issue. So you train in your model, then when you just put it in like out there for testing or for deployment, you facing this kind of problem. They say, okay, this is one is not like a generalizable for all the kind or for all the distribution of the problem. There are more things in the world more than the data you collected. I hope my question is clear.
Okay, as for the data collection, we try to diversify the data so that we are always looking for a statistically representative set of data. However, the collecting the data is can be costly and time consuming, and in some cases it's not quite possible to collect sufficient amount of data. So in that case, people often use augmenting the data. However, in most cases, increasing the number of trained samples can help increase the performance of the deep learning model of machine learning models. However, in some cases, just increasing the number of data may not be helpful. So there are because of the time limitation, I'm not able to explain in more detail. However, there is a quick test in machine learning literature to see if collecting more data can help or not. So if it helps, then we are trying to increase the number of training samples. However, if it doesn't help much, then we don't have to waste our effort to collect more data.
Okay.
So I hope
Okay.
this answers your question.
Yeah. Okay. Thank you so much, Prof. Thank you so much.
Okay. Thank you.
Okay, so Prof, we have two more questions from the chat box.
Oh.
Okay, so perhaps let me read the first one. So the first one is from Dr. Suman. So what are the considerations when selecting an example learning approach?
Oh, okay. Oh, okay. I see. The last question here in the bottom. Yes, there is a computational requirement because we deal with multiple models. The computational amount can be an issue. Therefore, people use the boosting idea in ADA boost, adaptive boosting, to reduce the amount of computation. So one idea, as in the Viola-Jones algorithm, people use a scheme to reject irrelevant part of the image, part of the data in early stage, so that we don't have to revisit that part of the image for unnecessary computation. That way, we can save the amount of computation a little bit. So my answer is to manage the computation requirement issue. People use ADA boost, adaptive boosting. So it uses the original boosting idea, but with reduced amount of computation. Okay.
Okay, so thank you so much. So I think thank you everyone for engaging question and Prof. Song for sharing your valuable insights. So unfortunately, due to time limitations, we have to conclude our Q&A sessions over here. So a big round of applause to Prof. Song and all participants for making this session insightful. So stay curious and keep exploring the exciting worlds, especially in the computer visions with machine learning. So thank you everyone. So let me pass it back to the MC of today. Thank you so much, Prof. Song. See you
Thank you,
again.
Dr. Oshin. Thank you.
Thank you.
Thank you. Thank you for your listening.
Okay, and that was Prof. Song and Associate Professor Dr. Uwe. Thank you very much. Right, distinguished guests, ladies and gentlemen, without further delay, let's invite the next moderator, Dr. Ong Lee Yang, to introduce our second keynote speaker, Dr. Mazlan Abbas, CEO of Favorite Sdn Bhd Malaysia, with the title of presentation, Humanizing IoT, Placing People at the Center of Technology. Please welcome.
Right, thank you. Okay, so here we will have our next keynote speaker. So ladies and gentlemen, it's my privilege to introduce our second keynote speaker for ICoICT, Dr. Mazlan Abbas. A person of remarkable accomplishment and a beacon of expertise in IoT, Dr. Mazlan brings a wealth of knowledge and experience to this gathering. Please allow me to present to you the brief profile of Dr. Mazlan. Originally, Dr. Mazlan graduated from UTM with a Bachelor of Electronic Engineering in 1984 and graduated from University of Essex from UK with Master of Science in Telematics in 1986. Subsequently, he achieved his PhD in Telecommunications from UTM in 1993. A noteworthy highlight in Dr. Mazlan's journey occurred in 2017 when he was honored with an honorary doctorate in electrical engineering from UTHM. Dr. Mazlan is a co-founder and CEO of Favorite Sdn Bhd. He has many active involvements in the area of IoT, such as listed by Analytical Report, Who's Who in IoT in 2022, ranked among top 50 global thought leaders on IoT and digital disruption by Thinkers 360 in 2019, top 50 most impactful smart cities leaders in World CSR Congress 2017, ranked top 10 in IoT, top 100 influencers by PostCap in 2017 and 2018, ranked number 20th thought leader in IoT by 2014 Analytical Report, and UTM Alumni Industry Personality in 2016. Before Favorite, he spent 2.5 years as CEO of Red Tone IoT and 8 years in Mimos Berhad as Senior Director Wireless Communications Cluster. He also spent 13 years in Celcom mobile operator, handling many senior management positions. Prior to Celcom, he spent 10 years as associate professor at University Technology Malaysia. He was adjunct professor for UTM, UTHM, University Technology Petronas, University Sultan Zainal Abidin, University Malaysia Unimai, and UTM. Currently, he is the adjunct professor for Faculty of Information Science and Technology, MMU. Dr. Mazlan is a frequent speaker at many major and established IoT, IR 4.0, smart cities, telco conferences locally and globally. He sits in industry advisory panel for several local universities. Adding to his accomplishments, Dr. Mazlan is a distinguished TEDx speaker as well. Ladies and gentlemen, please join me in giving a warm welcome to Dr. Mazlan Abbas. Let's welcome Dr. Mazlan.
Thank you, Dr. Ong. Thank you very much for the introduction. It was a very long one. I should have make it shorter. But anyway, I think it's a pleasure for me to be here and becoming the next keynote speaker. As you mentioned, I'm now the CEO of Favorite. You pronounce it correctly, Favorite rather than Favorite, Super Favorite. Some people mention it, pronounce it differently. But anyway, we are an IoT company, so I think it's also very timely for us to share in this event, the conference, because I've seen some of the topics that you guys have been presenting or will be presenting in the area of AI, machine learning, and so on and so forth. But the scenario may be not the one like I would like to mention here, mainly towards smart cities. The one that you have a lot of the presenters, the speakers, will be presenting more like healthcare or like autonomous car and something like that. Yeah. But let me share with you how smart cities play this role. And a lot of times when we talk about smart cities, we always have this issues of having smart city to be too technology based, and somehow we tend to forget that actually there are people inside living in the city. So nowadays when we build smart cities to make it successful, you need to ensure that smart cities are being built through the eyes of the people. The smart cities are being built where we place the people actually at the center of the whole technology that we want to deploy in this kind of cities. So I think a lot of times when we see the situation whereby, hold on, it's not changing. Okay, when we look at the aim of the smart cities, we see that millions of people, in fact, the cities will occupy a lot of space. People will be migrating towards the cities and becoming very congested. That's why we see a lot of cities are being built, green cities, what we call it, new cities in outside areas to ensure that people are being, not to be, living in one single city. So as we see a lot of these people coming to the city, becoming, burdened with all the things that, people are living inside there. So we have to find ways of how to ensure that the people, the citizens have a better way of living. They have opportunities to even generate their own business, sustain their own income, ensuring that the communities are more cohesive, they have more facilities. In fact, overall, we want to see the quality of life in the city. And of course, by managing the cities to ensure that all the cities run effectively, we have to ensure that the public resources make full of use, and the way that they manage the resources, the operations themselves, to be more effective. Yeah. But when we take a look at, how we can ensure that we live in a very sustainable city, sustainable in the sense that, the city not going to be broken down. And when we have too much, we are being strained by the issues and the challenges living in the city. And we also see that, like people like us who have been living in cities, some of us are living in hundreds of years of old cities. They have many stories to tell, the history of the cities and how they grow. But there are certain cities which is very new, what we call the green cities, the greenfield cities. Maybe they are still very young. There's no historical behind that. We can plan it well. But unfortunately, most of us are living in cities which what we call the brownfield. So brownfield in the sense that it's already being occupied by generations of populations inside there. So we see that the city themselves is like a breathing, living organism. We have this pulse, the temperature, the moods. They have different setting, and this is what we are seeing now. So one way for us to do that is to see how the city's mood look like, how the city's what we call the health also going to be look like. So when we talk about the health, we always look at the analogy between how we see smart cities health against human organ. So let us compare towards this the city health and the people themselves, humans health. For example, when we take a look at the vital organs versus the key infrastructure of the city, we look at the human, we ourselves have the heart, the lungs, the kidneys. These are the very critical organs that ensure that we keep us alive and well. Yeah. But for the cities, we have to ensure that there are essential infrastructures, transportation systems, the power grids, the water supply. These are the key utilities that become the lifelines of the city. So without them, it's very difficult for the city to function. And then we take a look at the immune system versus the security systems of the city. In the human aspect, we look at the immune systems that fight off any infections, any diseases, or keeping us healthy, as we see that COVID-19 last time, what happened. But we also want to see cities, which is, the whole security system make us very safe. We have law enforcement agencies, we have emergency services that actually can protect the city and the inhabitants from any threats that are going to happen. So ensuring all this safety and order within the city. And then take a look at the body's nutrition and diet versus the city resources and energy. In the human aspect, we look at the nutrition and balanced diet is very essential. For us to grow, for us to get energy and overall well-being of us. But for the city themselves, they need a very steady supply of what we call resources. They need water, they need electricity, they need raw material. All of this need to power all these operations and actually can support the whole inhabitants of the whole city. And then we take a look at the physical exercise of human versus the urban development. In human, we are looking at how we can actually, for us, regular exercise is to ensure our body remain very fit, remain flexible, strong. But the city themselves, you also need to have a better way of planning and development, because you need to ensure that you construct proper parks, for example, buildings, roads. So to ensure that all this city that grow can adapts to the needs of the whole population. And then if we take a look at the mental health versus the cultural and recreational facilities, we know that as human, the mental health is very important for our physical health, in fact, right? So we need activities like reading, meditation. We need to have social interactions. All of these are contribute to the mental health of the people. But in the cities, you need to ensure that you put some infrastructure or services or facilities like cultural centers. We need to put theaters. We need to put parks, recreational facilities. All of this provide a way for the residents, the citizens themselves to have some form of relaxation, some form of entertainment, social interaction. This can foster very good community and well-being. And then we take a look at aging and longevity versus preservation and modernization. In the human, we know that as we age, we have to do a regular checkup. We have to ensure we do some preventive measures so that we can prolong our life and ensure that we are in good health. In the city themselves, we have to also ensure the preservation of the historical sites. There's a lot of historical sites. For example, in Malacca, if you guys have been in Malacca, it's very historical city. So we have to preserve it and to maintain its heritage. So while ensuring that we also cater to our needs. And then we look at illness and recovery versus disasters and rehabilitation. For human, When you fall sick, you must have ways to have timely treatment, proper care, and in fact for us to recover. In the cities, we will face a lot of disasters, earthquake, floods, either it's natural or man-made. So we have to find ways of how to be very effective in responding to these disasters. We have some rehabilitation plan to ensure that the city can bounce back and rebuild themselves. And finally, we take a look at preventive care and proactive city planning. For the human, we do regular checkup, we do vaccination, we do health screening, all of this to ensure that we can prevent any potential illness. For the city, we have to ensure that all this proactive urban planning, we do some environmental regulation, traffic management, all of this can, in fact, prevent any issues of, from the city to ensure that they have very smooth functioning. Yeah. So these are the city health index. But a lot of cities mention that they are very healthy. They are number one city in the world. They are number two, number three. How do you actually rank the city? So we must find a way that if you want to rank a city, you must find a way to measure the city. Even people like us, we have to measure our health. So in fact, maybe at this point in time, we don't have a health indicator stating that you are 70% healthy, 80% healthy. But that is what we need to measure. And we use technology to do this. Yeah. So I will explain about how the technology will apply. So in a lot of cities, they claim like, these are the top 10 smart cities around the world by one of the organization. They have put a smart city index. They say Zurich, Oslo, Canberra, Copenhagen. These are the 10 smart cities, the top 10. Malaysia are being ranked here. They rank in 2023. We are number 89. There's only one city that is being indicated there, Kuala Lumpur, and being ranked 89 out of 140 something mistaken. Yeah. So, but how do they actually rank them? So they must have certain parameters to do that. So in Malaysia also, we have this what we call city indicators. Finally, we have come out recently with 85 smart city indicators. And if we have achieved 85 of them, you might be, achieve all the indicators and you become a super smart city. But of course, this total 85 smart cities is not that easy to implement. So it requires a lot of planning, vision, development, and also cost, to be involved inside there. So we in Malaysia, the Plan Malaysia, one of the agency under the ministry, they have put this into different categories. How the economy, the education, transportation, wastewater, culture, all of these are being put into a different category. And somehow, in Malaysia, for example, they have about more than 140 local councils. And 12 of them are being defined as city or very big cities. So they can implement big implementation of smart city projects. But there are also other local municipals, lower one, and district councils, which is smaller ones. So they don't have that enough money to implement a lot of these things. But how do you start, to ensure that you become like Kuala Lumpur, for example? They have been ranked in that kind of system. So what they have done is that there is this different category, what we call early adopters. So the early adopters, what they need to do is that they have 4 criteria. For any smart cities within Malaysia, the local councils need to comply these 4 criteria. One, they must have a very good blueprint, or what we call the action plan. So what we have seen before, there is the government have what we call the framework. Sometimes the state themselves will have what we call their blueprint. And finally, they will pass down to the local councils to have their action plan. Yeah, so they must be very clear in line with the government's framework. And then secondly, they must form what we call the Smart City Committee, the one that is a governance structure, the reporting structure, looking at the technology and the economic aspect, when they got projects, how they want to project manage it. So they must have a Smart City Committee. Otherwise, it's very difficult for them, and no one knows, who actually monitor the whole progress. Thirdly, they need to have what we call initial dashboard or mini command center. A very small command center is sufficient for them to view the information of the city. Yeah? And the fourth criteria, they have to comply 10 of the smart indicators that I mentioned earlier. Just now I mentioned about 85. Now you have about 10 of them. So these are the 10 selected ones which these smart cities have to comply in order for them to be called a smart city early adopters. Yeah. So these are the different stages of smart city. So they have 4 stages. As a small smart city early adopter, they have 10. And then if they have more, they 35 indicator further, they become a developing smart city. And then they become a leading smart city for with 60 indicators. If they have achieved all the 85 indicators, then they become a very visionary smart city. This is how I think we standardize the way that even if the smart city says that I'm a smart city, at which stage are you in? So if you comply the indicators, then you can claim that you are stage 1, stage 2, or stage 4 smart cities. So this is according to the MS ISO standards. So another thing is that as the topic mentioned, when we build smart cities, we also have to find ways of which smart city indicator which is important for us to start off with, because we don't have enough funding or the resource to do everything. So the best way is for us to understand and listen what actually the citizens' pain point, the public pain point. So how do we do that? So normally, previously, what we see, there's a lot of problems that being viral on social media, on media. You know, when we look at potholes are not being taken care of, and other, there is even one minister at one time. He had to sit inside the potholes to tell the local councils, hey, this is a very important thing you need to do to cover up this pothole. It's a very dangerous thing. But other countries, they even put some, they make jokes. And finally, they put some trees, crocodile, like, statue of the crocodile and so on and so forth, just to give a message to their local councils, because they are very slow in terms of responding. We see a lot of floods that's happening. Now it's raining nowadays in Malaysia, in Kuala Lumpur. And we hope that, flash flood is one of the things that very difficult to control. But there are floods which we know that, in certain months of the year, there will be floods going to happen. So what can we do? We can't always be reactive to any of this disaster. So we have seen roads are not being, selfish drivers costs then be incurred to all the citizens and so on and so forth. This is what something that we need to ensure that we can help the citizens themselves. So we have to focus, even in certain local councils, what happens if you have damage in your cars, the local councils actually have to pay that kind of damages, so it depends on which country. Some countries just don't care whether you have your car being damaged by a pothole or not. They just not bother. So when we take a look at the whole cities, everybody will be shouting. People are living in the cities. In which areas of the cities they say, I have flood. Buses are not coming in on schedule. There's no parking spaces anymore. Very difficult to find. Car park, the pollution is getting worse, the traffic is everywhere, crime is happening here, no one is handling my garbage. So these are the pain points of the citizens. So we need to capture that to ensure that certain resources are need to be placed, certain projects need to be, captured, to be implemented in that kind of places, rather than everyone is, having one project which doesn't give very good impact. So I think the first thing we need to have in our thoughts is that pain points of the cities need to be captured and we need to prioritize them. So we need to build a city which can give the trust to ensure that whatever that we complain have been captured and ensure that this being transparent. And we want the city to be very responsive in listening to the citizens' problem. And finally, they have to become accountable for that. So one way is for us to capture the data. citizen-centric. The citizen have to make the report. We have to make decision based on this data rather than we based on certain viral content. So rather than viral content, you have to ensure if this viral content is really have the numbers, a real number, rather than one person who made the complaint, and you have to take care of that. Rather than you have 10,000 people complain and you don't want to take care of that. So this is something which is we want the local authorities to be very accountable and responsive to the pain points. And how do we do that? So we need technology. There are certain technologies that cannot capture the black hole, meaning to say there are places where you cannot capture it, you cannot see it, you cannot do that regularly. So have to find ways of how to make something which is invisible to be visible. We need help in terms of putting sensors everywhere. But if we cannot have lot infrastructures because it's very costly to put IoT sensors everywhere, maybe you need to have human to do that. Human to make the reporting. Human become the sensors of the city. So we give the citizens themselves certain tools for them to capture the problems. And we can make this open source, or we can send the data to the local councils. So what we call the sense the cities. Sometimes people build just a simple app. I think a lot of cities nowadays have this kind of app who make reporting. So we capture the problems where they are, and we call this what we call the crowd sensing method. So you identify where's the problem, you take photos, it will geotag the problem where the location is. You send the data, you capture the data, maybe you put in some comments, and then you send the data to the local councils. The authorities themselves will look at the problems, whether this is very critical, and they will escalate these issues to the relevant parties, their contractors, who will resolve the problem. Their contractors might also have an app that looks at the jobs that have been assigned to them. So once they have solved the problem, they can close the case. And this closure, you only not the authorities can see. The app themselves will also allow the people who make the report to see that the case has been closed. There is a pothole being responded, and the pothole has being resolved, and then you see the action being taken. You know, you have a problem of your garbage not being taken care of. Now, when it's being closed, you see there's no more garbage. So all these insights is very valuable for us to understand what are the main problems, where exactly the problem, and when actually the problem occurs. So from there, you can prioritize the project, and finally you can build the next IoT solutions for you to make sure that it become continuous monitoring. So there are certain things. I think this one of the things I've seen in MMU. They have done this. Potholes previously we capture using mobile app, but I think what you have done, and I've seen this, you have a camera that captures the video, and then you upload it, you process it, then it will identify the potholes where it occurs. So then it shows onto the map, very instant. So this is very commercially viable nowadays. I can see that. I can see some companies have been offering this kind of services. But there are certain cases where other companies have done. While they are driving, they're also capturing other assets in the road. So signboards, bridges, and so on and so forth. So they capture along the way. It's not only the potholes, but they capture other aspects of the along the road. So then they can have these reports being assigned to the contractors. So when we build smart cities, there are three ways of building smart cities, or three kinds of smart cities. One, what we call the ROI-driven smart cities. So to ensure that you can make money out of that by rolling out new services, you get income. Normally, this is parking, you will have income based. Yeah? And then we have carbon-driven to ensure that you have a green city. How do you have to make sure that you don't generate pollution and so on and so forth, ensuring that there's no congestion happen, there's no pollution happen in the factories which is so near to the knee. So you have to make sure that it's carbon driven. And finally, vanity driven. If you have covered the first two, you can become vanity driven in case where you can see your traffic light have voice, you have your bus stop can even give you can talk, you have a talking billboard and so on and so forth. It's vanity driven. It's beyond than just carbon and ROI. but it gives you showcase that you have advanced application. So building smart cities, you require sensors. For example, in this case, you can see there's a lot of applications and data that can be connected, whether it's from the roads, from the people, from the cats and the dogs, buildings, rivers, and so on and so forth. All this can be captured. But I think the question just now, again, is which one that you want to make sure that you have to prioritize. Yeah. So one way for us to actually capture all this data, you have to find ways of how to get that data into a dashboard or into a command center. So what we call the urban observatory. So in Malaysia, what we have done, there is one urban observatory called Malaysia Urban Observatory. So they will gather all this data from different local councils. Yeah, so this is the plan. But now there's only several local councils in this project. But we want to have ensure that there are more local councils can capture this data and push to the highest level of hierarchy, which is the Malaysia Urban Observatory. Yeah. So in order to do that, there are various components need to be put in place to capture that. In this case, when I talk about IoT, we have 5 main components to do that. I think the lowest level is the sensors and the actuators, the infrastructure itself. You must have a way to do connectivity. You can send the data to the various from the various places, depending on what kind of connectivity. You have a middleware that aggregates all this data from different sources, and then finally you have to find insights. So you have to find applications, you have analytics to do that. Across all of this, you must have security components in all the layers. Yeah. So this is what I would like to share with you of how you can do it, and we also can help you to do this. Yeah. So what we do is that we must have what we call a smart city platform. As I mentioned to you just now, there are the third IoT middleware. These are the platform itself. So this platform is critical for you to collect all this data. So what do we say about this critical platform? So there are a few things. This platform is actually can help you to collect all the data. Yeah, it can ensure that the data can be from smaller amount of data to a bigger amount of data depending on the sensors, the scale. You have device management. Yeah, you can manage your data. You have device management to understand whether the data that from the devices are still alive. You have to find ways of how to do analytics, and you have to integrate various sources of data. That's the importance of this IoT platform. And the idea is, of course, to ensure that you have very improved urban infrastructure everywhere. It's always about decision making. Better decision making is always about data analytics. And it's nothing about off the air, you are being complained from viral information. No, you have to ensure that it's always it's data driven. Yeah. So there's a lot of case studies that's happening around the world. There are many organizations that have done this in different cities. We have seen Barcelona, Singapore, Amsterdam, Portland, Helsinki. All of them requires a smart city platform that aggregates all their information into their command center. So these are the brain, the one that I mentioned to you, the data that sends to the brain, and the brain have to make that particular decision. Yeah. So how do we do that? How do we collect all this sensor data to ensure that it can be pushed to the urban observatory? This is what we have done. This is what Favorite is actually offer the service. The IoT platform that aggregates the data from below, the sensors down there, being collected to a platform. And actually, what we want to ensure that you can simplify the way that you collect your data. Just now, I heard that someone mentioned, where can I get the data? And data is very expensive to get. Now, if you don't get the real data, then it's very difficult even for any AI or machine learning to do. Without data, for that is useless. So you need to capture it continuously from somewhere. So in order for you to continuously monitor that, put the right infrastructure, sensors, collect that continuously. So this platform can be connected to various connectivity or protocols from REST, MQTT, Core App, or WebSocket, doesn't matter. We do have analytics inside there, some element of analytics. But if you want to do more detail, you can extract the data out where you yourself, the one you guys have been doing a lot of analytics, can extract the data and do your own analytics externally. You have your own engine of analytics, machine learning, capture the data from the cities, and you can do your own analytics to do that. So the way that you want to do, you want to simplify the whole process rather than you have to build end to end. So let the software people just manage the data, analyze the data. Let the hardware people just focus on building the right hardware. So we will help you in terms of glue all these pieces together. So in order to do that, what happened is that I give you an example where we have done this with one of the smart city command center. They have this challenge of they have too many vendors having smart city solutions, everything in silo, so they can't see all the data. So everything and vendor is all data in silos, and they have different dashboard. So getting confused when they have so many dashboards, how they can see all this to be on. So our solution is to put that IoT platform in between by collecting their data and making sure that they can have a single dashboard. Now, instead of them to have multiple vendors here, now they have a single integrated system where they don't even have to buy another new one. If there is new hardware that comes in, they just use the same platform to do that. And from there, you can do a lot more of machine learning, analytics, all that. So this is how we do it. Yeah. So the existing applications can be connected directly. You might have smart parking, you might have smart waste, smart building, smart transportation, all being connected to the integration via the API. Or in future, if there is new sensors, you just buy the hardware and then you connect directly to the platform. And then we have the aggregated database. And from there, the command center can view all the applications within that scope. So I think it's the same thing if you're doing that for your campus. You have a smart campus, you will have a smart campus command center, aggregate all your existing smart solutions, and maybe aggregate new sensors that come in. And you can do the similar thing to do that. Yeah. So with that, they have a simple, straightforward, what we call that, dashboard. So everything's now being integrated there. So in this case, we are doing that for Putrajaya, one of the biggest local councils here in Putrajaya himself. So they can view their water quality, the lake quality, water lake quality. They have environmental, the wind and rain. And then they also have hydrology, so the levels of water river. So it's being integrated into a single dashboard. So from there, rather than they have multiple screens, now they have a very simple big screens to do that. So the public can view the contents, and the administrator can view more details of the data if you want to. Yeah. And of course, for example, we have this platform, a similar thing that can help you to build your own products. For example, one customer, they have built their hardware, but they want to build a solution. So to reduce the cost of the development, the cost of collecting the data. So we use this platform to help them to create more applications. Yeah, so they can value add to their current product. If they have the hardware, they can create a product. So then you can create many scenarios. So for example, our association, IoT Association of Malaysia, we have built a sensor hub which have different sensor interface that can connect to environmental, gas gateway, or even energy sensors, and then we can collect the data, push the platform, and then you can have your own analytics or dashboard. Yeah. So guys, if you're in your project, I've seen that if you want to collect your data, you can become one of the developer of the system by you can scan this, or you can go to our favorite.com and subscribe it and become one of the developers to collect the data from the sensors. Yeah. So other things, just for the last 15 minutes, is just to talk about this, is other than just that scenario that you have looked at, IoT can also transform other 7M of the smart cities. It can be some of the M's have been mentioned earlier, but you can do that for others. For example, the first M is we always talk about manpower, the cost of manpower. We cannot increase the number of manpowers, or we want to reduce the number of manpowers because we have too much labor intensive. So by increasing the productivity and lower the manpower cost. So smart waste, one example, potholes reporting. I've seen some local councils, they even assign people to ride on a motorbike and make reports. They go out one in the morning and make reports. Why do you have to do that? Sometimes you can use the public themselves to do that. You can even use monitoring from remote. Yeah, smart waste management, you can monitor everything from remote. Then we take a look at mobility, the way that you want to, in certain areas, from one place to another place, there's a lot of issues of congestion happening. We have to ensure that you have given comfort to the people who's traveling, safety. So you have smart transportation, you have cashless tools. So these are some other examples of the second M. Yeah. And the third M is that if you take a look at how we handle the machine or the infrastructure to ensure that it's running continuously, or you can predict if there is something going to happen. There's a lot of errors, accuracies, just using human. There's a lot of errors. But then if you want to reduce that, you can use IoT to do that. Street lighting, public transport, tracking. So these some of the examples that in this, the third M, which is the machine. And the fourth M is the method. I think a lot of times when we are labor intensive, we use human a lot. So we want to reduce the red tape of using human. We want to ensure there is no leakage, there's no problem of error. So we want to ensure that it's faster. We can reduce the number of processes. So for example, the citizen reporting app, you can make this, or local council app, you can reduce, you just use human to do that. So rather than, you use people call from the normal telephone, viral from the social media, you have a lot of problems to track all of these issues. Yeah. And then you take a look at the fifth M, which is the market. Maybe some of this innovation that's happening within the cities, maybe it applies to some cities, they can enter new market. There are some cities who wants to duplicate their solutions in other places. I've seen some cities, so they want to showcase their smart city solutions and they want to sell the smart city solutions to other local councils. And they can do that. Or they can build living labs for them to test it out, autonomous car and so on and so forth. And then the sixth M is that you can create new money. Of course, creating new products, IoT can help that. You create new products with connected devices, connected services. You can create new business models. Smart parking. Parking is one of the best way to do to get money lah. Yeah. So parking, you can even have tiered time parking. So in the peak period, it's going to be very expensive. The off-peak period can be cheaper, for example. Yeah. But you can take a look at this when you analyze the data of the parking system. Yeah. So all of this information needs to be fully analyzed. And then data-driven analysis is that the last 7M is the management part. How you can help all of this, making sure that it's always data-driven. You have to ensure that your management can monitor this 24/7 by 365 days, rather than you have to call them up for every week to have to compile the report. So it's becoming faster to do this by just clicking of a button. Transparency, no more that you massage the data and then you display. It's always continuously, you can see real time. So decision making is very important. So as a conclusion, I think for me, when we build smart cities, we have been now focusing very much on people-centric. To do that, we have to really understand where the problem is. We have to capture the problem. Once you identify the problem, then you can build a real smart city solutions based on this customer pain point. To do that, also, I think people like yourself, the guys in the research group, you have to ensure that once you have collected the data, you can make meaningful kind of data. So I hope in the future, conference, for example, you can use smart city as one of your application scenario, and we'd like to see more of this happening in the future. So I think with that, I would like to conclude my presentation. I pass back to Dr. Ong. Thank you.
Thank you, Dr. Mazlan, for the wonderful speech. We are now open for Q&A sessions. So everyone here, if you have any questions, you can raise your hand, all right, or you can type your questions in the chat provided. All right, here we have the first questions, right, from Dr. Go. So when IoT platform is collecting the data, how the data is being protected or secure?
Okay, I think as I mentioned to you just now, there are 4 layers of security or protection needs to be done at the, for IoT device. It starts off from the device itself. So a lot of protection is to be done at the firmware level to ensure that, data devices are not to be hacked, and firmware needs to be regularly updated. So once the data is being sent out, there's a way for you to do protection in terms of encryption. So some devices have done that. They have some encryption methods that they have sent the data. And once it's received at the middleware layer, it depends on the cloud capability, where the cloud have their own protection layer. I think that's a very trusted place. Unless you build the middleware at your own premise, then you have to find ways of how to ensure that firewalls are being protected. Finally, I think the weakest level, which I see, is actually at the level of the applications part, where a lot of data is being exposed is through the applications layer. So that requires authentication, password protection, and various methods. I think it depends on how you do it. Right? So that's how it is. Thanks, Dr. Go.
Thank you, Dr. Mazlan, for these answers. How about other members on the floor? Do you have any questions? You can raise your hand and also type your questions in the chat. Maybe from my side, Dr. Mazlan. So actually, I'm quite interested to saw that you have related the human health with the city's health, which is very interesting, which is very relevant as well. So based on the stages that you mentioned for the cities around the world to achieve the smart cities, so I have thinking about Malaysia. So in your opinion, right, how many cities in Malaysia, or have our city in Malaysia achieve any of the stages that you mentioned for smart city?
It's a good question. There are several cities that earlier, before the smart city indicators have been released, Kuala Lumpur, Putrajaya, Melaka, Johor, Penang. Some of these cities have been being ranked as smart cities. But now, to be fair to all, because everyone is stating it, why my city are not being called smart cities? So now, what happened is when they launched these smart city indicators, they want the local councils themselves to submit their report, and from that report, they will know exactly how many smart city indicators that they have complied. So it was recently, I think 1 month or 2 months ago. We haven't seen the report. Hopefully, once we have that report being released, then we know all the 140 over councils, how many of them have reached to stage 1 and how many have reached to stage 4. Some cities have even reached to 70% of the smart city indicators they have claimed that they have achieved. But I think it's still a big question about how they audit the data, whether they are saying that it's true or not, or whether how extensive their project when they said they have smart street lights. Maybe one street light they said they have complied, right? But that needs to be audited. So I think for this initial case, this is just an initial project that they have launched by Plan Nation. Hopefully, we have a more proper way of auditing the whole indicators lah. Yeah.
Yeah, and we also hope that our students in MMU here can have more exposure with IoT, because we have a major core data communication and networking, And we also have security technology and with AI majors as well. So basically, we have a lot of different majors of students that can play a part in IoT. So I believe IoT is the future of this technology, and also can able to help our cities to grow in a smarter way. All right, any more other questions from our audience here? All right. So in conclusion, right, the keynote session by Dr. Mazan has been a truly enlightening and inspirational experience for us. Through the journey of his remarkable accomplishment and insight of IoT, we have gained valuable perspective that will shape our thinking and actions of moving forward. As we bring this keynote session to a close, let us carry the torch of knowledge and inspiration by Dr. Mazan's words, and let us use this journey as a driving force to strive for innovation, excellence, and positive change. So once again, let us give a big applause to Dr. Mazan for gracing us with his insight, wisdom. All right, so yeah, thanks a lot, Dr. Mazan, for joining us here and let us know a lot about what has happening in Malaysia here for IoT. And we hope to see you again in future for any of our industrial talk in MMU or any other collaboration with our researcher here as well.
Yeah, it's my pleasure too. Thank you very much for the invitation.
Thank you. Bye.
Okay, bye.
Bye.
Okay, thank you, Dr. Mazlan and Dr. Ong. All right, ladies and gentlemen, and that was the end of the speeches from two prominent keynote speakers we have here today. We hope that you have absorbed as much information and knowledge shared by these prestigious elites. We are going to have a short break later, and you are invited to come back at 2 p.m. for the first tutorial session with Dr. Sumendra Yoga Ryan, titled Intelligent Transportation System, Advancement and Future Directions in VANETs, moderated by Dr. Kemas Rahmat Saleh Wiharja. At the same time, we shall have 4 parallel sessions, which the link is shared in the chat box. I think it's being shared now. Yes, okay, soon they will be shared. Okay, so these 4 parallel sessions are Quality of Life and Smart Living, chaired by Dr. Chong Siu Chin. Session 1B, Big Data and Analytics, chaired by Dr. Vera Suryani. C, Digital Community and Society, chaired by Associated Professor Dr. Tan Chu Kim. And the 4th one is Digital Healthcare, chaired by Dr. Kusuma Ayu Laksitowening. Okay, so be sure to come back here at 2 p.m. for more, and we'll see you soon.